right, so we are ready to go. This is, can't believe it, week number 5 of the class already, which is kind of wild. It goes pretty fast. And so we are going to continue our introduction to the metal shop. Remember, the first part of the first like section of the course is really getting introduced to the different areas. So it's a little strange that it's still introduction, but it's the second week. But this is the first round in the metal shop, and then we'll go deeper into all of these ideas once we get past some of the badging processes and some of the basics in these spaces. So we are working on our second part of the intro to the metal shop, which is mostly going to be covering metalworking processes. So not so much what are the tools and what do they do, but how would you work with these systems and sort of what are the secret pieces that are hidden just below the surface inside the metal shop. That's going to be our game plan. We're going to cover a big one, soldering, brazing, welding. That dynamic is one that is really very interesting to tease out, because those get used in many different places throughout what we're doing. Like we're going to get, in a couple of weeks, we'll get to electronics, and we'll be doing lots of soldering, and sort of seeing how that fits in with metalworking is an important part of what we do. And brazing and welding are also fun to put in there. We'll talk a little bit about tempering, and now that we have a kiln, I suppose we can even explore that a bit more, tempering and then annealing. We'll talk about the lathe and the mill, just to identify what those are, how they fit together. A little bit of an intro into CNC, and then the water jet as an extension of that. And then some electroplating and some other like interesting odds and ends as we move on to the last bit. And this is, it feels a little bit more high level. So one of the nice things is that as we move through the course, we'll step back and take more perspective views of what's going on. And this is definitely a week that feels like it fits into that camp. So first up, let's talk about these 3 items: soldering, brazing, and welding. Some of these slides have too many words, and this is a good example. Soldering is just when items are joined together by melting and putting a filler metal, the solder, into a joint. That solder is always a lower melting point. I wouldn't try and like have these definitions, but this is taken from Wikipedia, November of last year. And Wikipedia is always a great resource for all these sorts of things. But basically, you have a filler metal that is separate from the metal that you're connecting. Solder is, I think, best seen by picture. It is often a very small connection. It's not for things that are physically very large. As a general rule, soldering can range anywhere from electronics, like you might see here in the bottom right, where you've got this little perfect Hershey Kiss type shape. You can have solder stations that are very fancy. And then there's soldering pipes, or sweating pipes is sometimes another name for this, where you can put solder between the joints of a copper pipe. This type of plumbing's been used for hundreds of years, works great, and would recommend for sure. But then there's also soldering for jewelry. So here somebody's making a ring, and this looks like some sort of a chain. You can absolutely solder together jewelry, and it works really nicely. One great benefit of soldering is that it's a low temperature filler metal. So you have almost no risk of damaging the original metal piece while soldering. The filler has to have a much lower melting point temperature. And that's really what saves the original. You're never gonna, if you're trying to solder, you're never going to cook. If you're using the solder correctly here, you'll never melt the metal pipe, right? The same for the ring or the keys. It's especially important in electronics. In that case, you want to get the temperatures as low as you possibly can, because the electronics, if heated up too much, will just fail, right? And so you have to be a little bit careful with that, but basically it's the same process. Soldering is just trying to make a bonded connection without hitting the temperature too high. Then there's brazing. Brazing is sort of the next level in this progression. This is melting and flowing a filler metal, very, very similar. But the filler metal, and even though it does have a lower melting point, I would call this a mid-temperature filler metal. So brazing is where you can do a lot of the same things. And I put the same exact image in here. This is like, depending on how you want to camp it, it's sort of in the in-between land of soldering and brazing to sweat a pipe. But brazing is most generally it's almost identical to soldering, except that the filler is very similar in temperature. It makes stronger connections. So you can see like a bike frame going together over here, or a few places like that. It can be done a little bit more industrially like this, where you have a filler metal and then you pass it through a furnace and it wicks its way in a conveyor. This can work really well. You can have this brazing go on up here. It can be used to fix cracks. If you have a giant democracy defining bell sort of thing and you want to fill it in, you may braze the connection in a crack. And so those sorts of things can be really helpful, but brazing is often done where the temperature of the filler and the base material are pretty close. You can actually braze with exactly the same material, and a jeweler would really know this well. So jewelers, I think, are the most knowledgeable. One of the people in the class last year definitely knew more about brazing than I did by a landslide. She is fantastic if you ever get a chance to talk to Ada, but her knowledge about different brazing sticks that you can buy, different brazing fillers. Like if you're making gold jewelry, you can get a golden style brazing filler. If you're making silver, you can get a silver. Sometimes you want the look, sometimes you want the same actual material for different reasons. When they're the exact same material, you get a really nice link and there's no expansion contraction problems. If it is a different material, they might expand and contract at different rates, which usually isn't a problem for like jewelry you'd wear around normally. But I don't know, if you're worried about making metallic connections and then going into space with them, this is a thing that you're gonna have to think about. Aluminum is most often brazed, is typically a good way to do it, although we can sort of weld aluminum here with another process. But welding, I would say, is separate from the other two in that really you're using the same metal to connect things. So instead of a filler metal for welding, you're really using high heat to melt parts together and then allowing them to cool into one piece. Instead of using the metal as sort of a glue, welding is really making two parts one part. And so welding is what you'll see in all these different forms. Weld lines often have this sort of a structure where it comes along like this, and you've got this bead of weld there, or you can have these large structural pieces, or you might have rebar that gets spot welded together. You can even have underwater welding if everything's working right, which is I had a student a couple of years ago that was absolutely certain he was going to be an underwater welder. I would love to follow up and see how that worked out for him. But there's all sorts of different places where this can get used. But this is the thing that you might have gotten a badge on last week. But the big thing about welding is that it can be with or without a filler metal, but it takes two or more metal pieces and brings them together into one continuous piece. If you had X-ray vision to look in between, the real differences that you'd get are that for soldering and brazing, you most often have three separate pieces where you can see sort of boundaries between the materials and how they work. For welding, you'll get a big heat affected zone, but everything becomes just one metal. You've usually taken it to the point where all of it becomes molten, and the filler is just there to fill in any gaps that you might have. But then if you're a good oxyacetylene welder, you may not even need to have a filler metal. You might just take one plate of metal next to another plate of metal and then be able to melt them together into one continuous piece. I definitely don't have that level of skill. That's a hard one to acquire, but it is definitely a thing you can do. So like trying to relate these three things is a little tricky. There's soldering, brazing, and welding. And it's an increasingly hot process as you do that. When you talk about different metals like steel and its melting points, at some point you heat it up enough and it will go from solid to liquid, just like water, ice turns to water. When you heat it up enough, metals will do the same thing. It's kind of wild to watch that happen. And pewter really does that nicely. And Lisa has plenty of experience with pewter. Hopefully we can hear a little bit about that later. But and lots of other metals also. But in this progression, essentially just to jump from one category to the next, you're thinking about hotter and hotter processes. And at any point, Lisa, I know you actually have a ton of experience here. If I'm saying things that are incorrect, feel free to hop in and just let me know. But for this, your soldering and brazing pieces, these are generally lower where your filler is not, you're using a filler for these two, and you're not that close to the melting temperature of the base metal. Whereas welding, you're always right up against the melting temperature of the base metal, and you may or may not even need the filler. It's an interesting distinction, and we're going to do a lot of these over the entire course. Soldering, we're going to look at mostly with electronics, and that's going to be, we're going to have this week of metalworking, then we're going to have a week of textiles, and then we're going to do 2 weeks of electronics right after that. At which point we've already ordered, and I have in my bag somewhere around here, a whole bunch of electronics that we'll be playing with and soldering and making into different pieces. So we've got all sorts of things that we'll be soldering and playing with over time. So if you've gotten a little welding in, it'll be kind of neat to see similarities and differences with this soldering process. This grid is probably not worth trying to take in all at once, but if you really want it, I really nerded out on this question at some time in the past. And so if you wanted to draw some distinctions, do you have a different base metal, melting point of filler metal versus the base metal? Is the bronze structural? And this is, I think, an important piece. When soldering, it's not usually very structural. For jewelry, it might be, but not for you wouldn't build a house or a skyscraper by soldering together pieces. You want to absolutely weld metal on that scale. Filling gaps is really done well by soldering, and ideally for brazing, you're letting it wick in between the two metals, so you're not trying to fill gaps. And how deep does this connect is another interesting question. For soldering, it's a surface level connection. For brazing, if you do it just right and the metals are super clean, it can go into the metal just a hair. But for welding, you really are going to get a deep connection from one metal piece to another. And so that's a big part of the welding strength, comes from linking the pieces together at full force. So that is a quick overview of those 3 processes. And we're going to see a lot of soldering and hopefully a lot of welding this week. But the next thing to do is to sort of pivot from there, because we could go into metallurgy, into that aspect of metallurgy real long if we wanted, but let's talk about tempering. So tempering is a neat process. You might have seen rainbows across the surface of a metal before. This is a process that does a few things, but basically metals change color when they're heated. They do that for a number of reasons, but you can get tempering temperatures out of the color of steel. And that's because as we live in an atmosphere that has oxygen in it, and as you heat up metals, they give up their electrons pretty easily to the oxygen in the air. So you build up really thin layers across the surface really, really quickly. If you're in the metal shop this week, try and notice if you see any color on your metal. That color will indicate the temperature that that piece of metal has been raised to, which is a little wild. Like a person who's good at this will use the color of the metal to actually tell what temperature it's been heated to. So you can really get very precise, and it changes colors based on an interesting science concept called thin film interference and the oxide layer thickness, which is really cool. And so I totally have nerded out on that quite a bit, but sometimes you leave it as a feature. So in this sword, they tempered it in that way. And so you can see that it was a little bit cooled on the outside, a little bit hotter on the inside. And so it's got that sort of a look to it, which is a fun look some people go for aesthetically. In jewelry, you might do that. You can do it across copper. It's a look called fire scale that you can try and manage really tightly if you want to. These are rusty chips off of a lathe. But in jewelry, often, or in like this watch, fire stain can be hidden. Like you might plate over it to make it go away so that you don't have to worry about it while you're manufacturing the piece, but then you can cover it up so that it's not evident at the end result. But if you've ever had metal jewelry that over time starts to look weird, it could be that that plating started to come off onto your wrist and then the fire stain starts to show through. So that's an interesting detail here. But it all has to do with a very thin layer across the surface of the metal, an oxide layer, where the metal has been bonded to oxygen, basically rusting in a very thin layer that you can kind of see through. Now metals, while we're talking about colors of metals, there's a few reasons why metals might have different colors. And the first one I think is fascinating. It's the same reason that stars are glow. and this is, I'm positive that you all know this, but to my high schoolers, it's mind blowing when you say the sun is not on fire. There's not enough oxygen there. It's glowing hot from radiation. And so it's just a thing that materials do. When they get very, very hot, they glow. And we call that black body radiation because it's imagining like a perfect, not light emitting material. You heat it up enough and it'll still emit light because of its temperature. And we can use that to tell the temperature of things by their color. For a star that's blue hot, it's very, very hot. A red hot star is actually a little bit cooler, and it's sort of exactly the opposite of what you'd expect from your tap on the faucet at home. But that said, it works really well to tell how warm things are. And it's why when you've watched a movie where there's a blacksmith in it, Game of Thrones or whatever, in that case, when they pull a hot piece of metal out of a forge, or in your case, right after welding, it's red because it's glowing hot. And as it cools, it stops glowing and it gets cooler and cooler. And so that glowing starts to come down. Our sun is actually white hot, so it's in the middle range for temperature, which is fascinating. It looks yellowy because the sky is blue. It diffuses the blue light through Rayleigh Jean scattering. Okay, that's a lot of science, teacher. Rusting is another reason why you get colors. And so rusting can be red. That's the common iron rusting color. Or the Statue of Liberty has turned green as a similar rusting process. It's a patina is how it's usually called for copper or a bronze material, where you get this sort of a look. And for iron, it's this flaky rust that you get. But either way, it's still oxygen bonding to that metal. And so it changes the physical nature when you get the oxide of the metal. It becomes flakier and more brittle. It'll break apart. So that's something that you need to think about. Water will help this go much, much faster. You can even use other materials to make it go faster than that. And so this is another reason why you might get different colors for metals. And then mill scale is another one. So this is, if you have hot rolled steel, when it comes out of the mill, it will have mill scale on it, which is sort of a bluish flaky surface. And it does a lot to protect a metal from rusting. But once it's on there, it protects until it starts to get a crack. And then it becomes like a very shortcut for rusting to happen. So mill scale is usually something that a person who works a lot of metal will leave on the piece right up until they get to the very end where they want to dress it so they can paint it or make it nice or keep it so that it will stay a certain way for a long time. But definitely don't try to rust through it. It's got a lot of stuff. And even if you do weld to it, there's a crack just underneath it somewhere. It's a surface layer that's pretty easy to knock off with a hammer. And if you've stood around and watched somebody try and do blacksmithing, which we don't quite have the equipment here to do, you'll see mill scale come popping off of the metal. So there's some really interesting reasons why you might get metal that's temporarily or permanently different colors, but it's good to try and put that into a bucket if you're trying to understand what's going on. So that is sort of our reasons for, so thinking about soldering, brazing, our colors of metal, but then lathe and milling. So these are two major processes that are worth looking at. They're both full day classes, so not expecting you in any way to try and get these classes done, although they're pretty fun. But just to have them in context is really helpful. The lathe is pretty often called the king of the machines. If you were to try and imagine the Industrial Revolution, it basically kicked off when the first lathe was made. Once you have the first lathe, now you can start to make precision parts. These are two videos that I've got linked into these slides. They're like 20 minutes long and actually fantastically well done if you want to nerd out on the history of the lathe. And you can go and watch this and how it really enabled the Industrial Revolution. Before the lathe, it was very hard or almost impossible to make a screw. To make things that were perfectly round or very long and straight was very difficult. But by turning, you sort of get that precision. And each time you increase precision, you can revolutionize how things are made if you can make them repeatably and reliably the same way. So once we started to tick up our skill at precision by 1 or 2 orders of magnitude, we could build much better machines. Essentially, you had like stone grain mills before that, where you'd have a large windmill and all the mechanisms were very, very large and oversized, so that we could build the gears and pins well enough to fit that scale. Once you introduce the lathe, now you could have controlled precision at much smaller sizes, so your machines and mechanisms could get much smaller to go along with it. The lathe is fascinating that someone with a monstrous amount of skill can almost make it self-replicating, where you can make just about everything you need for a lathe on the lathe, which sounds like magic. I would love to see a video of someone building a lathe from a lathe, just to watch. But that's the rumor. And so here's a little bit more about our lathes. These are our two over here on the left. This is the little green one. This is a German model that we have in the space. This is the bigger one. These are the two that you'll play with if you're getting badged. Lathes, because they're so old, one of the things that's really common with older tools and older processes is that the older they are, it seems to be the more language, the more terms they have tied to them. And so you'll learn words like the saddle and the ways and the bulkhead and different like weird, the tailstock. Some of those words may not feel super strange, but they're specifically tied to lathes and how they work because they've been around for hundreds of years. And at that sort of a time frame, you start to get a lot more built up terminology that goes along with it that's specific to these machines. So a lathe is really good at turning metal. And so here I think is a nice example of what's going on. A lathe spins a piece of metal, like this shaft is what's being worked on. And then this is the tool that's cutting into it. And it may seem like that's not got a lot of capability, but usually there's this threaded rod along here. So you can use it to cut threads. You can use it to do controlled things. And because metal doesn't really change size, or actually changes size super predictably, you can use a metal lathe to make pieces that are within tolerance to insanely high levels. Think about the aluminum case on your Mac, or the crazy scale that you might have things built, the pistons inside of a car's engine. Those are all turned on a lathe, and that gives you the ability to have very high precision, very high control. So the lathe is a fascinating machine, and it really was the start of all of this machining ability and the basis of the Industrial Revolution, which is kind of wild. Then a lathe sort of turned up on its end, where instead of turning the work, you're turning the tool, is a Bridgeport, the mill, where the spinny part is this cutter head. And you can see that this cutter head is just sort of chomping away at metal. The Bridgeport is fundamentally not that different from a drill press in that it is a big spindle that is mounted on something. It's a drill press where the table part moves. However, it has exceptionally high torque and power. So with that, you can just chew right through metal. You can use it to surface things. You can get nice straight cuts. You can register and make different complicated parts on a metal lathe, on a Bridgeport, but it is definitely got some skill to it because you're manually moving those things around. You need to turn this knob here, will move the bed of the Bridgeport left and right. And this one will move it forward and back, I believe. Maybe that moves it up and down, but you've got these different cranks that are manually moving in different directions. It starts to become a chance where we can think about how end mills work. And if you've used the router table, these are very much the same as router table end mills, but just applied to metal. So they need to be hardened a little bit harder. They often have more cutting edges. And a person who's going to use the Bridgeport needs to think a lot about how fast they can cut through the metal. So there's like speed limitations and those sorts of things to take into account, but it's fascinating. This is a great video. It's on here twice. I know that that is true, but he goes through this particular video. I'm going to play and mute just a little bit. He goes through and explains the Bridgeport and the CNC right next to each other because fundamentally they're very close cousins. This video I definitely recommend that you watch. I'll put a link to it in the Foundations chat, but he goes through how you'd make a very similar piece in the Bridgeport and the CNC lathe, just to get a sense of how those two machines relate to each other. But a Bridgeport, fundamentally, a mill would let you do lots and lots of production processes, but it has a limit to how well you can turn the knobs. And if you wanted to make a perfect circle, you have to do little tiny movements on both of those X and Y dimensions. Whereas for a CNC, those little tiny motions aren't really a problem. CNC is an acronym that we're going to use a lot over the duration of our time together. And they've got a lot of possibility. If I were to pick one thing collectively about what is magical at MakeHaven, I would say it's the category of CNC machines that can take you from like you can be an artisan here and do beautiful work. And I don't want to decry that in any way. But my own personal favorite that feels like a superpower here is that you can design things and then have computers cut them for you to better precision than you could do yourself and efficiently and in a reasonable amount of time. Like this metal piece here, this is actually, I'm not happy with that, the way that it looks. We got a much higher quality one, but this was cut on a machine in under 10 minutes out of a block of aluminum. So this is CNC lets you take designs that you have on a computer and then produce them in the real world using different amounts of controlled motion. And so like this right here is a CNC, or is the Tormach CNC in the metal shop, and cutting out of that brick of aluminum that becomes the graduation stamp. This is another close-up. It's a GIF that should be active, but you know, it's apparently not. You can also use the Gerber or the Shipoko. Those are all CNC machines. They all fit into the same category. But really, we want to talk about them here just to put them in context with the Bridgeport. Because the Bridgeport is their spiritual grandfather in lots of ways. They move in the X, Y, and Z dimension. You can go in a few more dimensions, but mostly for us, it's just that. And the computer controls the motion. So the Gerber, you're able to move around in very large areas. The Tormach is for small motions and very high precision. It can cut through metal without a problem. You just need to make sure that you're using an end mill that's got the right amount of toughness. And so if you wanted to use a CNC machine, there's an entire workload that you have to do. And we're going to build towards this skill set over the course. CNC milling on our Tormach means that you're going to go through at least 7 steps if you want to try and plan it out that way. You need to have an idea. Then you need a 3D model of what you're going to make. Almost always you need to have that be computer designed in your CAD software of some sort. Then you're going to need another CAM software to take that model into a machining plan, export that or process it into G code. Then you're going to need to get the CNC itself. Actually, that's before you even touch the CNC. Then you need to set up the CNC, home it to its own place, run the CNC, and then do the cleanup work. Running a CNC is a lot of little steps, each of which is very approachable on its own. And when you put them all together, you get a nice, you can have really nice products that get made. This last slide is all stuff that I've done here in the last year. There's plenty more to look at. In addition to the CNCs that we have, all of them are 3-axis machines. You can have 5-axis machines and more, where you can rotate in addition to doing other things. And so those are really cool opportunities to add into this. But computer numerical control is essentially just a big spin up from the Bridgeport. The Bridgeport lets you move in the X, Y, and Z dimension, and the CNC lets you go above and beyond. Now you don't, for the sake of being clear, you don't have to do the Bridgeport before you get most of our CNC badges, but it's worth it, I think, to go walk in there and turn the knobs and sort of feel the feeling of it. You turn the knob and it moves in one direction, right? Without turning the machine on, without any, no risk to safety or any of those things. But just to turn the knobs and feel what it feels like, and then know that a CNC is turning that mechanically with a computer drive. So there's lots of interesting options there. But one extension that is totally approachable this week is the water jet. And I would love to see people using the water jet this week. It's a badge that's relatively quick to get. It's probably faster than the table saw to get this badge. It's got its own design software if you're already good with vector design software. And we all played a little bit. You have your maker logo that we made in our first week. You could absolutely take just that one design, plop it into here, and make something on the water jet and have your metalworking week planned and done. But the water jet basically uses ultra high pressure water. I think it's 60,000 PSI, which is insanely high pressure to blast through metal. And it may feel like that's nonsense, but at the same time, mountains are cut by water, right? Which is kind of wild. Like the Rocky Mountains are shaped by rivers passing through them. Water will cut anything. The molecule is unbelievably hard. And so water will blast right through. We do give it a little bit of an extra kick by adding in a garnet, by adding in some sand. And that sand helps. It's another exceptionally hard material. And so with enough time blasting through high pressure water and garnet, you can cut through sheet metal, you can cut through very thick metal. You can cut through ceramics, apples if you want to for some reason. But any 2D vector shape will work really, really well with our water jet. There are higher end water jets. I've seen one run at Yale's, at one of the Yale labs that will do 5-axis on a water jet. We have a 3-axis one. To get this badge is a relatively straightforward process. If you've already used the laser cutter, you've pretty much got the skill that you need to run this. But it does have its own entire software pipeline. So you have to play the game of this pretty carefully. You'll need to go onto the website for the water jet. You'll need to download the software, get a code through Lior, who will give you the code to use it. And then keep in mind that running this machine consumes garnet and a lot of electricity. So there is a cost per minute of running it. It's not very expensive, don't get me wrong, but it's not one that we can run for just absolutely for free. So you'll want to keep that in mind. Your badging process, though, is like the complimentary gift, right? So if you wanted to do something and try and get it done within the badging process, you could absolutely do that. But I suppose provided it's not this cut, that would take hours to do, but you can absolutely do it. Another thing that I saw people do with the water jet is you can use it to cut through plywood. MDF wouldn't be good. MDF would start to get wet and then ruined. But if you cut through plywood, which takes water fairly well, it will cut and sand it at the same time, which is kind of wild because you're passing sand through the water. So it cuts and sands all at once. These are different examples of water jet projects you might make. This is cutting through a stone that's being held on both sides. And so over time, you can make this cut. Getting it to be a straight line cut is a little tricky. There's some balancing act to happen there. But if you've ever seen inlaid marble designs, those are cut on a water jet. Someone designed those and then laid them down and was able to grout between them well enough that you can't really see the difference. This is cut out of glass, not plastic. You can absolutely cut through glass or mirrors. Here's etching into a stone. This takes some level of art. It's not super, super easy to do etching, but it's totally possible. And then here's little brackets and thin plate steel. You might have, maybe you've stayed in some rustic cabin somewhere on an Airbnb and gotten to see railings like this. Those are very high-end art pieces installed, but not super hard to do on the water jet. You just need to have the design, and then you cut it out of a piece of sheet metal, clean it up, and then paint it black. Done. So if you're way into this sorts of style, or if you have other designs that you'd like to cut out, you can absolutely do that on the water jet. These look like little brackets or hooks. I had a good conversation with somebody who was using a water jet to cut out surgical pieces for doing research on different like brackets to hold things during surgery, which is kind of wild, cutting it out of titanium on a water jet. So there's all sorts of different reasons why you might use a water jet. It's fascinating. Kate last year made stained glass window cuts on the water jet, which is a really incredible process to be able to see the sorts of things that you can design and then make. A big part of that design, if you're thinking, ooh, stained glass windows, I'm in. A big thing that she had to contend with was the cutting kerf. The software actually helps you with that. But if you wanted to make pieces that fit together, you're going to have to plan for it probably a little bit nicer than the software will allow. So it's totally a thing that you can do, but you just need to be conscious about how would you manage to get a fit as tight as like this eagle made out of stone of various colors. There's certainly the science of that, and then art to take it to the next level. And so the water jet is really one that I just want to say, if you're going to try and get one more badge, this is the one I would recommend. And if you wanted to make some cool, crazy project, the water jet is a place where you can button that up pretty tightly as just a one-stop shop for this week. So it's totally a cool one to try because you can cut through anything: stones, metal, wood, all sorts of stuff. And I would strongly recommend you give it a try. Tile even down here is neat. There is one thing that you need to be careful about with the water jet, is that if it goes wrong, like here you have a blast head, and that tip to the water jet, if it runs into something like a clamp or the material that you're cutting or whatever, it's designed to be especially hard so that it can withstand all of that water coming through. But like we talked about last week, if something's very, very hard, it's also probably brittle. So it does, when it hits something, it doesn't tolerate it very well. It's meant to just deal with the forces on the inside. So if it hits something, it's probably going to shatter. And that part we know is going to break. So we have replacements, but they're $200 a pop. So like you go slow, you be careful, and you need to know that that's a possibility that could happen. It hasn't happened many times to many people, but the like classic story that's told here is that the one member who will remain unnamed, and I actually don't know who they are, they had a real bad day where they broke one, and then they paid for the replacement, and then that one broke, and then when they left, they got a parking ticket. It was just a bad, like terrible. Hopefully that happens to no one at all. That's the worst luck. They found it right there. But it is something that you need to keep in mind, that if things go horribly sideways, you could need to pay $200 for this. Twice. Hopefully not twice. Hopefully no one will have to do that twice. It was a very unlucky day. But for that is, the water jet is totally worth doing. And I think that there's plenty of good starter projects where you don't run into that barrier at all. I have never broken a tip on the water jet. Kate has run the water jet a lot, and she has not broken a tip. There's tons of different people that have used this machine very successfully without any concern for breaking the tip of the machine. So just keep in mind that it can be run safely without much concern, but that's essentially the highest risk that you're going to have. And so it's good to keep in the back of your mind. Now, the last pieces I think are fascinating, and these are quirks that just basically boil down to metalworking because it's metal, which is electroplating, electroforming, and chemical etching. These are, I would love to see someone do this. For all of these electrochemistry things, there's some really cool stuff that you can do where you can take a metal and you can coat it with other metals. So this may sound like an unapproachable process, because it does totally feel like mad scientist work. You need to get strange chemicals, you put them in a bucket with a metal piece, then you put electricity in, and it all goes weird. But basically, you can use a metal salt solution to like take some metal here and coat it with copper. This little shoes like this were super common in the Midwest. I don't know if they're common here in Connecticut, but maybe you have a grandma with these little shoes from somewhere in their house. Perhaps you've seen those. People will like cover those shoes with a conductive paint, and then you can do this electroplating process so that you can cover them in a bronze or copper metal surface, which is really fascinating. It preserves them for forever. That's the reason why it's done. And you get this little look of like the baby's shoes, but you can totally deposit metal onto the surface of conductive items. And that, for some reason, for some things, it's not that important. But for like this bucket and these nails, if these are iron nails and an iron bucket, iron's very cheap, but that zinc layer is what keeps it from rusting. So that's galvanized nails, or a galvanized bucket is going to have this look. That's the zinc across its surface. And that zinc layer keeps it from rusting, which is really nice. It's put on through an electrochemical process where it's able to be conducted on. You can also do brass coating to make things look like they're made of gold or brass, if you can spot the difference really well. What's up? So, iron rust. Yes. That's it. Ooh, good question. So iron rusts, and you have to put it in a solution for this to work. How do you stop it? The rusting process for iron is a much slower process. Oxidation happens at many different rates, and rusting is like the slowest of those. A very fast oxidation is that thin layer that you get, or actually fire is an oxidation reaction that happens really fast. The electroplating happens much, much faster than the rusting chemical process. So you'll finish plating the steel, or you'll finish plating the iron with zinc well before it has time to rust. So you're like outpacing it with the chemistry, which is a really interesting detail. There you can go way deep in the weeds for the chemistry of all this metal work if you want to. And so another one is chrome plating. Chrome plating is another one that's really nice. You can get this fun look on the surface of metals. And so all of this can be done. It's pretty cheap to buy this copper sulfate. It's kind of a toxic chemical, but it's pretty approachable to get your hands on. You just have to dispose of it carefully. And then a copper anode can just be a copper pipe that you use here to get this copper to deposit on things if you want to get a brass coating or a copper coating. And it's a neat look. You can also do etching. And so etching is a really interesting trick. If you have, I don't know about you, but I always have a socket set rolling around. And if you find it hard to read the numbers, this is a video where someone said, I really don't like that it's so hard to read, and I can etch into the material, take off its chrome plating, and then get exposed a much larger, easier to read number. So that's another interesting process. And this is really exposing sort of the internal domains of metals. You're exposing sort of the hidden lower layers. And it was really used well on some pieces of armor, where you get this etching to put a design across the surface of a plate of metal armor. You're just touching the surface, so you're not really hurting its structural integrity at all, but you're able to put a ton of detail onto a piece of armor. This would have been like a king's armor. That's, that wouldn't have been a normal piece, but it's tons of detail that you can add in. And why don't you deserve a knightly helmet with all sorts of crazy details? It seems like lots of fun for everybody to have. Or you could just win at Comic-Con, right? That totally could be a thing. But this process is one where you really need to go deep into the weeds. You need to think about the specific metal that you're working with, the etchant that you might need, and the process that you want to go through. But it can be really, really cool. But it's also, I would say, a more advanced process, for sure. And so just like stepping back from that, we've covered a lot. What are the things, and actually what I want to do is hop back up to the summary that was all the way at the beginning, because it's been a while. We went through soldering and brazing, the welding process, tempering basics, and just the very, very basics. The lathe and milling, CNC as a concept and sort of how it fits. The water jet, which I strongly encourage everybody to get that badge. It's a good one to try. And then electroplating and etching. But your goals for this week are basically just to try anything in the metal shop. Any project that you're interested in, anything that you want to do, you should go for it. Keep in mind that you've just got the week, so don't take on something that's huge. You may want to choose to do something from these grab bag ideas, which we think are going to be pretty approachable within a week. So that could be that you're, I did add it to this. I will, if it's not, I'll add it to the Slack for sure. Oh yeah, maybe I didn't. I'll make sure that it's public and do all that. But there's the, let's change the zoom so that this is readable. But in here, there's the side table example to make that out of legs. And I just saw Lior bought new metal bar. And so for one $25 piece of metal bar, you can make a few side tables or a coffee table without any problem. If you try and buy a set of coffee table legs on Amazon, it's going to cost you like 60 bucks. It's like 3 times as much for probably less metal, actually. A lot less metal. Yep. Wind chimes that you can make from just pipe, and that's actually a lot of fun to do, and it can be really nice. A copper wind charm that's more like just bending some wiring into something that's really delicate and beautiful. Or you can cut anything on the water jet, anything at all. I think that would be lots of fun to see. It's a good preview for our 2-dimensional fab unit that's going to come after Thanksgiving. But if you're already good at vector stuff, the water jet might be an easy push. And you can use the designs that we had from the first week where you sort of made your logo. You could just produce your logo in stone or metal or something like that without having to make something totally new. But with that, that's essentially what I wanted to make sure that we covered, because there's lots that we could go over in the metal shop, and there's really an unbelievable depth that's there. You can get a metallurgy degree if you want and be a machinist, but those are going to be things that are well beyond what we're trying to do. We're just trying to get the intro and get ourselves up and running. Other good metalworking projects, I've seen people make braces and brackets. Somebody last year made metal chopsticks. That was kind of fun. There's all sorts of different things. Ileana made, last year you did the hairpin legs, right? And so those are tons of fun. And we talked about those last week, didn't we? I think during the class.
Yeah, a little bit. The biggest issue was that I didn't use the metal fabrication because I was fortunate that basically keep lasting.
Yep.
metal, and it was not something that I felt like I could do here.
Sure. Yeah.
But yeah, it was pretty much like blacksmithing, got the metal cherry red, and then hope for the best.
Yep. Yeah. And so for anybody, I don't know if you could hear at home, but she heated up metal bars and to cherry red at a certain point, and then bent around a small anvil or another metal bar, and then you could tack weld it into place on some brackets, and it worked really nicely. And so there's all sorts of things that you could do over the course of the week, and we'd love to hear what your game plan is for what you're going to be up to. The projects that you're going to take on here, I think I want to make sure that we say there's only so many hours in the week, so don't try to go after anything that's too wild. It's going to take more time than you think in the metal shop. That my like major thing that I've learned about metal shop projects is that they go pretty slow. So don't they don't, you're not going to be able to race through them as quickly if you're wondering about what they're going to take. Just sort of make your estimations. Ooh, there was a good question in the chat about what would I recommend for looking into brazing at MakeHaven. The big thing about brazing, I would say, if you're trying to do brazing here, we have all of the torches and the resources and those sorts of things to do it. The clamps, you can hold your back into this brazing. So the big one for brazing is you want to, if you're trying to connect things. Oh, I froze for people. Okay. All right. Can we hear me now? Maybe. Internet connections on. Okay, good. All right. So if you're trying to do brazing here at MakeHaven, the big thing that I would look into is getting your own brazing rods. I don't think that we have a stockpile of them of any different type. Lior's nodding that we probably don't. Oh, we do. Oh, we do. Great. Do you know what kinds off the top of your head? The normal bronze brazing rods. Bronze and steel brazing rods. Cool. Copper. So we have some brazing rods if you need them. Got it. Okay. So let me re-say what Lior said for the microphone. We have one type of brazing rod that works generally for many metals, copper, steel, and some others. But if you wanted to get a specific type, like if you wanted to match color or if you wanted to have a certain specific property, you'd need to get some of that. So we just have like the general brazing rods, the stuff you'd buy at a big box store, probably. Right. Hmm. Right. Yeah. That makes sense. So Lior is saying that there's two different kinds, and you'll want to think about the runniness or the viscosity of the metal once it's brazing. The question was, what kind of soldering or brazing would be good to rejoin an aluminum chair's arm to its seat for patio furniture? Any like instant gut thoughts? Yeah, I think that's a good point. We'd need to know what alloy of aluminum you're looking at to know its melting point and sort of how it goes, which is tricky. And the Mig Spool Gun, you can change it out to Mig weld aluminum, right? Yeah, the spool gun only does aluminum. Okay, cool. So it does, the Mig spool does a wider range of aluminum alloys than the brazing does. We could probably turn on the microphone and pass it around. Yeah, and so another question is there a specific facilitator that would be good to help? And we have a lot of facilitators. I would message the group of them and say, hey, anybody have particular experience? One of the things that's great about MakeHaven generally is the facilitator access, because you've got all these people who have experience some of which do these things professionally, and then they come here and sort of play around in the same sort of space. And so if you're really interested about something that's fairly niche inside of one of those areas, I think it's probably good to send a message to the group of them. There's also facilitator channels in Slack where you can reach out and say, hey, I have this really specific idea. Does anyone know anything about it? I've gotten actually amazing responses by asking people big questions like that in different ways. I got tons of pointers on steam bending when I was really interested in getting started with that. I've gotten pointers on other different topics. And the resource pool here is actually wildly deep. So if you have a question that you want to ask about even a very specific thing, like what alloy of aluminum is most likely for my yard furniture, you might run into someone here that actually knows the answer. And so it's totally worth it to ask it into the cosmos of Slack. So absolutely, I would endorse that you ask those questions and see what you get back from people. Let's see, I'm going to stop the share, make some adjustments, and come around and do a few things. But I think we hit the major points of what I was hoping to get to. The big ones are there's a lot of variety in brazing and welding, but there's tons of opportunity in that space also. And the lathe and the Bridgeport are good to go in and turn the cranks a little bit, feel what that feels like, even if you're not going to do the class. But definitely try the water jet if you can get a shot. It's a fun machine. There's tons of opportunity to make things with it, and it's really a good time. But that brings us to the end of our lesson part. And so now what I'd like to do is have the show and tell, where we can share a little bit about what we did this past week, what badges you might have gotten, and what you're excited about doing this week. There's tons of opportunity to do that, but just before we do, and I should have not stopped sharing my screen, because one of the things that I want to show off is, and let me do this, is that there's a couple of updates that are worth mentioning. Here I've taken and put on the Foundation's website, where there's Ashley and I and JR, but we also added in pages for each of you in the class. And so you're all in here. We have links so that they go to your websites. And if you wanted to, we can go in and start to do show and tell based on the things that you post to your webpage. So it might be easy enough for us to click on and say like, hey, what did Renee do this week? Click in and see what's happened on the page. If that works well for you, we can easily start to do that if you ever want to. And then the other thing, this requires you to do a little coding, to think a little bit more, to plan out, and to, if you finish Sunday night, it may not be possible to have it documented by Monday afternoon. And that's totally fine. But one thing that's a little bit faster is we have this Foundations album that we made literally minutes before we started class today. And I want to invite everybody who's in the class to this Google Photos album. Not because I'm, expecting that you would post all the time, but if you've got a cool photo of a project that's come along, or you've got other fun stuff that happened, this is a photo I took of Renee's project. You can post them in here, and we'd love to start showing off all the cool stuff that you guys do for any photos that you'd want to share. And so this is a neat way for us to learn from each other. It can be really cool to see pictures just pop up in here. It was a lot of fun with the people last year. And it can also be a fun way for MakeHaven to show off the cool things that you're doing and sort of the neatness of this space in general by aggregating a lot of these or showing off some really cool ones. So this Foundations 2022, which is the year that we will graduate, but still feels like the distant future, even though it's not. That is the album. I think I already put a link to this in the Foundations chat, and I can go through and methodically invite you by your email addresses. I just didn't get to do that in the few minutes before class started. So I'll do that before I leave. But that said, it's without further delay or updates or checking the rest of the things on my little post-it note of don't forget them. I think it's time for show and tell. And so it looks like we have the microphone ready to go in the room. Great. So what let's do show and tell for the people who are in the room first. There's the 4 of you that are here, and then there's a few people who are playing along at home. And so I'll be able to switch around the camera and point at people here. And if you're in the space and you would like to do, if you'd like me to pull up a web page or something, I totally can. So just let me know and I'll be able to do that and sort of tie that in together. But first up, do we want to
Do you want to just pass it around?
pass it around to James? And then people at home, as soon as James starts talking, give me a thumbs up if you can hear him.
So I actually have nothing to show today, but I will tell that I found a derelict white oak desk in the hallway in my apartment building that's like totally gorgeous. The tabletop is totally gorgeous. So I think that kind of like inspired me to make one of these tables. So I'm going to refinish that desk at some point and then build a table.
That sounds like a lot of fun.
Pretty cool. Yeah, I already ripped it all apart. So like the top is awesome and the rest of it's all falling apart. So I'm gonna make a desk. Pretty cool. And that's it.
That's a nice free find, and for like 20 bucks for the steel, boom, there you go. Yeah, that's all right.
So this week I got badged on the horizontal bandsaw and also the pneumatic hand tools. So that was all really cool. The horizontal bandsaw is pretty crazy. It's really cool to see how that works. And I think I want to get the water jet badge for sure, because I think that's what I'm going to use to do my project. I haven't fully decided what I want my project to be at. I have a few ideas. One of them is like cutting a material to be a clock face out of the water jet. So like, like a blob amorphous shape out of stone or mirror or something, and then like putting a clock mechanism in the middle of that. I think that could be cool. But yeah, that's what I did. Oh, and then I finished my woodworking project yesterday. And it's drying on the 48-hour table somewhere.
Should I go grab it? I'll go grab
sure.
it. You should talk about it.
Okay. Yeah. So I ordered some Eastern red cedar from the Ozarks, which is where I'm from. Well, I'm from Arkansas, not the Ozarks, but yeah, I got this awesome redwood, and this is my first project I've ever done on the lathe. So it's pretty simple. I don't know exactly what it is. It's like maybe a dice cup or a planter, or it could hold candles. But I think it's cute and I'm really happy with it. Corey was a huge help. And Mara really helped me too. She's around here somewhere. But yeah, it's really awesome. So yeah.
What am I doing this week? I'm either going to do some legs for a table or redo a big mirror that I practiced one go before I started this course on the water jet. So I might try it again, like a asymmetrical mirror. So it's either the legs or that. But this week I finished my project too. Here's my cutting board. Oh, my cutting board. Finished it. There's that charcuterie board, whatever we want to call it. Oh yeah. But yeah, so I'm doing this week, either the mirror or some legs.
I really like how this piece has so much character in the wood. It's got a ton going on. There's all this color that's happening, and it's this like lovely golden tone. So I don't know if the color correction is going to come out the right way, but it really is like it's got a nice look to it. I think it's the beach, right? I think it's it's a fun shape. Yeah.
Hey, Corey, can you pull up the website?
Oh, yeah, I can pull up the website.
I don't have all the pictures, but I have some of them. Of stuff
You're
that
totally
I
good.
badged on.
I'll do this and the website, and then here. Well, this is the live test to see if it all worked. Hey, all right. See my progress. Intro to
There we go.
metalworking.
Yeah, so at first I was torn more between the hand plane restoration and the table legs because I'm going to be pretty busy this week. But once I get more guidance on how difficult it would be, I am leaning more towards the table legs. Since I didn't get a chance to finish the woodworking project, just because I didn't get the aprons on. And that's pretty much the metal equivalent of the woodworking part, just getting the legs onto the top that's already made.
Yep.
And I ended up getting badged on the hand tapper a while ago for tapping threads into plastic, but I can use that for metal later if I wanted to have things I could screw in or unscrew later. And I did the wire wheel, bench grinder. The bench grinder would be good for sharpening tools and stuff, wire wheel for cleaning things up, and the welder. I had to watch this video several times because I kept psyching myself out like, I'm going to electrocute myself. I'm going to cause a big fire.
Yeah,
I'm going to quote Leor, not have a lot of fun. It's going to feel like a lot of not fun.
It can feel so high stakes, the welding game, and but it also has so much cool opportunity. But it takes a while to get comfortable. I would encourage you, if you're intimidated by it, try and do it more, which feels like the exact, it's like if you're afraid of heights, taking a few extra steps up on the ladder. Yeah. Yeah, it totally is.
Try finding 100% cotton socks. I've never seen those before.
Well, and like the 100% cotton socks is important, but not the most important. You're going to be covered, right? Like jeans and the guard thing over it. I spent an unreasonable amount of time in polyester while camping, and like definitely can feel the difference between the two materials, and the polyester would just like melt if any metal got onto it at all while it was that hot, whereas it might bounce off of cotton. The cotton would make it just a little bit longer. And that's really what the whole thing's for. But it's a scary safety video for sure, because things can go wrong. What's wild though is how I'm constantly amazed by the welding process, that it's high current electricity but so low voltage that like you're almost at no risk of any, you can be touching the metal table and completely fine. It feels wrong, but that's how it works. It's a little scary, but
One less dangerous, I'll take it.
yeah, less dangerous, so we're in. Yeah. The underwater welding still seems like such a bad idea because it's electricity that's doing it there too, but it's the same deal, low enough voltage that it's not a problem. So it's just kind of mind-blowing. Awesome. There was a question from the great beyond, maybe. Is that Lisa? Is that you?
I was just clearing my throat, but actually I do have a question.
Yeah.
The charcuterie board, where did you get the beautiful wood?
It's on.
It's
Yep.
on.
It's on.
Oh, okay, yeah, I just got it in the back in the store. Yeah, it was just in the back.
Nice.
Nowhere special.
It's the beach, right? And so, and I think the board was like $4.
Right. It was $4
Right.
For like the 4-foot board, was it? Or maybe.
It was longer. I feel like it was pretty. Anyways,
We lost a lot of wood.
yeah, we did. It's all right. All right. So let's see. We have then the people who are at home. We'd love to hear from all of you for your show and tell, just to hear about like what you did this week, what was your favorite badge, and those sorts of things. And Lisa, you are unmuted. Do you wanna tell us about your experiences with
Sure.
metalworking? Because you've got a lot.
Yeah, so I was away all this week from the next day after our class till the moment before this class started. So before I talk about what metalworking I have done in the past, so the only thing I managed to do was to watch the video for the horizontal bandsaw. And boy, I feel like when I come in and see it for real, it's somebody's really going to have to show what's what, because on the video it just looks like there's so much to keep track of there. I also want to learn the water jet. I'm not exactly sure what I'll do with it, but I just know I'm going to love what I can do on it. So that's what I think I'll focus on. So I used to be a pewtersmith. When I say used to, I still have all the materials. I've moved on from there because pewter is an extremely soft metal. And once you've made something and you sell it or give it away, a lot of people just don't know how to take care of it. So I moved on to harder metals like silver, copper, brass, gold. And but it was really exciting what I did do. And I don't know, hopefully you'll be able to see what this is.
That's incredible.
So this is a
Whoa.
menorah. It's a menorah that I designed. And with this master pewtersmith that I studied under and worked with for so many years, we figured out how to do it. And basically these tubes, well, you have to design a pattern out of paper that will create these. And then you just with a bandsaw or a handsaw, it all depends, cut each piece. Then you've got to pound it around a stake. So it'd be a steel stake like would be used for any metalworking. But so then they have to be seamed and closed somehow. And normally, like these joints here were soldered, but these were fused. And what that means is I cut little minute pieces of the same pewter that all of this is, and lined them all along the seam this way, took the torch, it was an acetylene torch, and very carefully ran the flame along the edge. And because the pieces are much smaller than the body of the piece, they'll melt before the body will, if you're very careful how you direct the flame. And I had to do that for each one of those and solder them down to the base. The base had to be soldered. All that means when you're doing multiple solder joints in this kind of metal or silver or gold or any of those, you have to strategize the order of your soldering so that there's different hardnesses. So there's easy, medium, and hard. So you want to start with hard solder, which takes more heat to do. Then the next joints that you do, you step down to medium, it's going to take less heat. So the soldering you did before will not melt when you're doing the next ones, and down to easy. So this took a long time to do, but
That's so
Yeah.
wild, Lisa. I am mind blown impressed. That's
and thank you. And pewter melts at, if I remember correctly, somewhere around 425 degrees. So you can see why you don't have a lot of leeway when you are working with it.
right.
I grabbed a few other things just to show you. So something like this, which is a bowl where I cut a base for it, designed a base that I used a jeweler's saw for that. So it looks like a coping saw, but the blade is much finer. But then this, so it started out as a flat circle, and I turned on the lathe a form for this. So it's like making a bowl, but you're not doing the outer part of the bowl. You're just doing an inner depression and making it really smooth, and then taking this in with special mallets that won't mar this. So they're wound paper, so they're not hard. And you're going to pound this progressively from one form into another till it sinks to this depth. And then I soldered pewter wire along the edge to give it this lip. And one last example is I made this little creamer, a pitcher. So again, I had to start with a flat pattern that I designed that when bent around would form this. And this is, again, this progressive pounding of it. So slowly and slowly it curves around a stake, basically. And then a spoon stake, it really was for this part to do that. And then this was bent around a different one and soldered on. So this gets soldered closed here, and the base gets soldered on. And then also this is highly polished. So it was on a buffing wheel. There's certain compounds on a very soft cloth muslin wheel to shine this. But the inside is satin finish. So I used can't remember if it was a steel or a brass brush wheel to do the inside. But what I just did last week, because so here we are on Monday at the class, and then Tuesday morning I go to Guilford to a jewelry class. So this is what I'm working on now, which is it's 3 layers of copper. The colored layers are copper that I enameled with a torch rather than in a kiln. And they were flat discs that I cut out, and then actually I stamped out the smaller ones. So there's a kind of a stamping thing where you slide the sheet in and there's a hole there, and you take a mallet and you hit this disc that hits down and cuts a circle out. But the back is silver, and there's a reason why I did that. Is because I don't like the feeling of copper against my skin. Copper really tarnishes, and then it gets it on your skin, and it doesn't, feel good. So I backed it with silver, and then I made a rivet. I drilled a hole through everything, and then I used silver wire that's got a hole in it, like silver tubing, and there's a certain way to make a rivet out of it. So and then, before I attached all of that, I soldered these half loops on the back so that I'd be able to suspend it. But actually what I'm going to do is make a chain from scratch, and then I have to make a catch. So that's what that is. And just lastly, this is something that I made that is, oh, wait a minute. It's called fold forming, which is something that Ada does. Ada is a master of fold forming. She was in my class for a bit of time, but so it starts out as a flat sheet, but it's just really how you have to keep heating it. You have to heat these metals in order to bend them because it softens them. And then the way you put it in the vise and fold it. So it was really just a flat piece of copper and folded in half. So it was like a rectangle to begin with. So we started with a rectangle, and then you progressively pound along here, and it actually starts curving. It starts curving. And when you finally get it to where you want it to be, so then I added a patina to that. What you see as blue was me adding a certain chemical to that caused the copper to turn that turquoise color, versus the other, which is a combination of, I let it stay there. The heat of the torch discolors or colors the copper, and if you like it, you keep it. And then, of course, as it ages, it darkens too. So that's that. Those are my examples.
Lisa, that was like a very brief masterclass in how to all these different metalworking projects. I'm blown away. Item 1. And item 2, I would love to pick your brain at some time in the future.
Okay.
There's all sorts of cool things to learn and take from that. And I'm sure that anybody in the class would love to hear more. So
Sure.
awesome.
Thank you.
Awesome work. And I hope you enjoyed your time away, and we'll see you in the space this week.
Yeah, I hope to catch up.
Cool.
Thanks.
Yeah. Let's see. Alina, you're the next up in my view of people. Would you be willing to unmute and tell us what you're up to this week?
Yeah, no pressure to follow that, Lisa. So I did a bunch of the just quiz badges, as many as I could roll through on the website. Excited to actually get in and try some of those things out now. I think for my project this week, I've been on a roll making Christmas gifts for family, so I think I'm gonna stay on that roll and do some wind chimes if I can. I'm gonna challenge myself and try to make them actually sound nice together and get the notes to sound good. We'll see how that actually turns out. But then also I have one more woodworking thing that I was working on this week. So while I'm working on Christmas gifts, I've got a lot of babies in the family. And so those like block puzzles where you fit the shapes into different shape holes are slightly too young for the baby in the family. And so what I've done instead is put little pictures of family members and just use the jigsaw to cut out these little holes and then the Dremel to sand out the edges. And then I'll cut out little blocks and I think maybe either burn or maybe use the Shipoko to engrave like the name of each family member in there for the topper piece. But that's one person off my list.
Yeah, that's lots of fun, and what a good gift. Yeah. Let's see. And then your audio cut out for a bit. Do you have any exciting plans for this week with metalwork?
Yeah, that was probably what cut out. My plan for this week is to do wind chimes.
Oh yeah.
And I'm gonna challenge myself to actually make them sound nice. Have the tones sound good together.
Yeah, you can. I mean, if you want to lean into the high school physics, you can totally decide the length and then pick your tone based on the length if you want to get them exactly right. So I can send along a website link for that.
Okay, I might snag that.
Yeah. All right. Sinam, if you're around, would you like to share what you were up to this week?
Yeah, absolutely. Let's see. This week I came in to get badged on a couple of things. Also, can you guys hear me? Well.
Yep, we can see you. You're a little quiet, but we can hear you.
Okay. So I came in to get badged on a couple of things, including welding, some saws, and a drill press, which I had already used, but apparently did not have a badge on. So I got all of those out of the way, and I don't have too much time this week, so I actually was planning on maybe making this thing. This was a project that I'd done a couple of years ago at school, where I just kind of designed this toolmaker's wife, and it has different. Basically, you just need to use different tools in order to get it to be this. So you need to use I did the lathe, and then you have to do like a lot of precision working. But I had never actually built it. This is someone else who built it. So I was maybe thinking I would go ahead and build that, but it would take quite a bit. So I do have the drawings for it. I could kind of follow through and see if I could actually build it. But I think I'm not going to do that because I don't have that much time. It might be a fun project. I might get started with it and follow through at some point, but I might end up just doing the metal legs for like a table that would come. It's like a coffee table that would go in to so that I could like pull it towards me when I'm sitting on my couch. So instead of legs, instead of being like this, turn it around like that, and then kind of just like move it inward sort of thing. That's what I was thinking.
That makes sense, and it would be easy to do with the metal legs. They'd be plenty strong.
Yeah. So
there you go.
Probably what's gonna happen.
That little vise is really cool, but I think you're right. It would be a lot of work between the lathe and the Bridgeport. You're going to need both of those machines, and pretty extensively.
Exactly. So it's probably maybe sometime down the line.
Yep, that's all right. Cool. I think the table will be a lot of fun. You'll have fun with that. Awesome. And then let's see. We have Norm. If you're around and able, we'd love for you to unmute and tell us what you've been up to this week. What you're planning for the upcoming week.
Sure. I was away a part of last week, and I'm going to be away this week too. So it's this from the sublime Lisa to the ridiculous. But you know, I did badging and for the coming week, I'm going to be working on a water jet project, which led me to understand that I really needed to know more about Inkscape 2, because, you know, to do the design, I needed more skills for that. So I'm working on that. And in the meantime, I just happen to be planting bulbs for the spring, you know, and I had some crocus bulbs, and squirrels and chipmunks eat them. So a metal solution to that was something I wanted to find. And so I got wire mesh and snips and needle nose pliers to form a little planting box for the crocuses that will keep the friendly chipmunks away while letting water and roots go through it. I did do that, but mostly it was kind of badging and understanding more and more fully just how unskilled I am at things and how much I have to learn.
But that honestly, like the metal screen over a bulb, that's brilliant.
Well, it can't be just over a bulb. Because then they would borrow under. It's an actual box. You know, I just formed the box with the needle nose and snipped it to shape with the with snips.
Huh.
It's on my website if you want to see it.
Yeah, that's pretty clever. I can pull that up. You got the website up and running.
We'll see if it works. Anyway.
Yeah, where'd you get the idea for the? Had you seen this before? Had you done any of this?
No, and I don't think you can buy them. Although people must do this. It would be on the weekly projects.
Got it.
And then down below.
Somewhere down here.
Yeah, a little bit further. A little bit further. I might not have. You know what? If I can share a screen, I can show you. It might not have been posted soon enough.
Yeah, I'll do the stop share. You should be able to share your screen. It is a funky step with the Google Sites that you have to press publish for it to go. Otherwise, it just sort of lives in your space and you can see it, but the rest of the world can't.
I'm just checking to see if is that showing it?
It's getting there. Yeah. Yep.
It's not worth going through.
Yeah,
you know what? There's something wrong and it's not worth the trouble, but it's a wire box. Maybe this will do it. Yeah, so this was my starting point. This is my fear. This is the material. These are the tools. This is just forming 3 sides of the box and cutting the remaining parts, which I'll bend over, put dirt in, and hopefully the bulbs will last longer than they would otherwise.
Yeah, that is.
It's also beautiful.
Brilliant.
It's not quite as beautiful as Lisa's stuff, but then again, it's only going to be squirrels seeing it. So.
Well, yeah, and you're going to bury it, so like, can't look too nice. Yeah. Well, that is. I would say that counts as metalworking for sure. You're making little cages, very functional metal projects. That's awesome. It sounds like everybody is having a good time and hopping into ideas and projects and getting things going and underway. I'm real excited to continue this journey to see what happens this week. Because the badging sessions are fun, but then it's really great to see creativity come out in these like produce it weeks. And so it'll be fun to see what sort of things that everybody makes. If you have any questions at all, please feel free to reach out to me, to Ileana, to any of the metalworking facilitators. It's a big group that we've got for support. And so please feel free to reach out, ask for help. I intend to be in the space on Thursday and Sunday for sure. And then, we can work out other details if we need to. And let's see, I think that if I'm not blanking, looking at Ashley, seeing if there's anything that Oh, yes, and there's also a survey for a short survey to try and understand how the woodworking unit was. Any thoughts, ideas, suggestions? We're always trying to improve. So anything that you've got for feedback there, you can expect another one to come through for the metalworking stuff when we hit the end of this. And so it's in the foundations chat, right? And if you could go in there at some point and fill it out, we'd love to get feedback from all of you. So with that, it's 8:32 and we did it, everybody. Now it's time to make stuff in the metal shop. So for everybody who's playing along at home, have a great night and we'll see you in the space this week.